Greetings everyone! Today we're going to explore solving log equations. Make sure you have your notebook. If you have a foldable, great. If you don't, just jot these down and pause your video when needed. Alright, so let's talk about why this is one of the awesome things about logs is how we can directly tie it to the real world, specifically to tornadoes. So most tornadoes last less than an hour, travel less than 20 miles, kind of basic information. And we actually have a model that uses logs to determine the speed of the tornado relative to the distance that it travels, okay? So in this case, if we take a look at this tornado that struck Moore, Oklahoma, May of 2013, it traveled 17 miles. What was the approximate wind speed? So in this case, because we know the distance is 17, then we can calculate. So in your calculator, if you were to type in 93 times log, and your calculator automatically does base 10, okay? If it's a different base, we'll have to talk about that, but it does base 10, so you don't have to worry about typing that in. But then type 17, close the parenthesis, then add 65. We get approximately 179 miles per hour, which would make sense for a tornado. So in this case, it's really easy to say whether an answer is close to true or not. And just, this is a true tornado situation. These are actually some pictures from that tornado. Here you can see how the pathway is so direct, how your neighbor could be gone, the neighbor's house could be gone and yours could be completely intact. So let's get into some of the more basic algebra topics. So first of all, a refresher, don't have to jot this down, but we've been solving with common bases. So we've been transforming this 8 into a 2 and saying 2 cubed. If the bases are the same, then we no longer need them, and we set the exponents equal to each other. So that idea of if the base is the same, we just use the exponent. That's something we're going to carry through into logs. All right, so this we definitely want to jot down in our notes. So in this case, similar to the review we just had, if the log is isolated on each side of the equation, one-to-one relationship, and they have the same base, then we can drop them, okay? Then we can isolate and just set the basic algebraic equation equal to each other. It has to be specific, one log to one log, same base to same base, okay? That'll make a little more sense later when we have more than two logs, but it has to be a one-to-one relationship, okay? So then, of course, just basic solving here. What do we got? X equals 4. And you could check in your calculator or basic mental math here, right? 16 minus 7 is 9. So I'd have log base 5 of 9. 4 plus 5 is 9. Get there the same way, right? So what do we do if my equation only has one log? Okay, a one-to-one relationship's easy, but if I have one log, then I have to convert, okay? So that conversion that we worked in the last lesson. So here I've got a base of 2, so we're converting log to exponential. If you need to review, watch previous videos. The base becomes the base. The answer becomes the exponent. What's remaining becomes the answer. Okay, that's how that's just a saying that's always stuck with me and makes sense. The base becomes the base, the answer becomes the exponent, and then the rest for me just falls into place. So in this case now we can actually solve because it's going to be something you could type in your calculator or use your exponents card, the yellow card we had in class. Either way, that's going to get you to the answer a lot easier. Let's take a look at this one. Let's approach it the same way in the sense that we're going from log to exponential, okay? So in this case, the base becomes the base, the answer becomes the exponent, therefore what's remaining is my answer, right? So then again, something simple that we can calculate and get an answer. Right? Similar look, there's one log. So typically with one log, you're going to convert to exponential. So let's look at this again, my little saying. The base becomes the base. The answer becomes the exponent. What's remaining becomes the answer. The difference here is we have to solve for x. So the opposite of fifth exponent is fifth root, or you could use your perfect roots card and say what to the fifth is 32. I'm open to how you go ahead and solve that, but either way we get 2. Okay, I've only got one log, so again, same thing, we're going log to exponential. So in this case, the base becomes the base. The answer becomes the exponent. What's remaining becomes the answer. So this just makes it a 2-step problem, right? So we're just going to go ahead and say that we've got 8, and you just got to add that 4 over. So sometimes you'll have a little bit of Algebra 1 work to do afterwards, right? All right, so in this case, here's where we have to be a little more careful, you guys. I only have one log, so yes, I want to go log to exponential, but I can't do that until I isolate the log. Okay, we've been isolating so much this year, isolating the squared function, isolating the square root function, isolating the exponential function. So we have to isolate the log, meaning do the Algebra 1 work first. Okay, kick that 7 over to the other side. Now the log is isolated. Okay, so in this case, now I can convert. Now I can say that the base becomes the base. The answer becomes the exponent. What's remaining becomes the answer. A negative exponent, okay? Don't put this in your calculator. It'll give you a crazy decimal. I don't want decimals. Negative exponents get kicked to the bottom, right? And then I can take 10 to the third, which would get me to 1,000. Okay, that would be a crazy decimal. Just write it as 1/1000th. All right, next one. So far, this looks like a single log, sort of basic, but let's see what happens. If I try to convert to exponential, watch what happens. 2 to the x equals 5. Is there a clean number that can take a 2 and get it to a 5? There's not, okay? So here's where you're gonna need your calculator. Scientific calculators do have the log function, but it doesn't do base 2. Scientific calculators usually do base 10, okay? So if you got the Chrome add-on for a graphing calculator, that would be helpful. If you have your graphing calculator, awesome. What you need to look for is the log function under math, okay? So I'm gonna actually create a new slide to show you on my calculator. All right, so check this out. I have access to an online calculator here, so we can talk about how to deal with this log base 2 of 5 equals x. So in your calculator, you'll notice in the left column, there's a log button, okay? So when you click that, it creates a log, but notice there's no base there, okay? That's implying base 10. Well, that's not helpful. I have a base of 2. So let's go over to math instead. And let's go over to log base. So notice right away when I click math, if I scroll down, 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 I see log base. Look what that does. That log button creates a base that I can type in. So now I can fill in a 2 of 5, and then I can press enter, and I can arrive at the irrational value that I expected. I knew 2 to something equals 5 had to be a crazy number. Okay, so this is irrational. This number does keep going. So make sure you round to 3 or 4 decimals unless I say otherwise in the directions. Okay, so if the variable is not within the log, you can use your calculator. If your log button does not create a base, go to math and then scroll down. Okay. All right, so just to summarize, notice that to solve some of them, you could use your perfect roots chart. You're always welcome to use your calculator right now. And sometimes you have to use your calculator. Key things, make sure you always isolate the log first if there's one of them. If there's 2 of them and it's a one-to-one relationship with the same base, your life is a lot easier. So kind of a lot of little different topics. So Make sure if you have questions, please visit with me. Let me know. As always, make sure you check out Google Classroom, okay? I'm trying to keep up with Power School. You know me. Let me know if there's anything going on there that you need. And if you need help, reach out, okay? Definitely ask questions. And you know what? If you're still listening to this video, kudos to you. And this week, since it's the year 2020 and you're watching this at home, the first 3 Algebra 2 students who email me with their mailing address and the password this week is in sync might get a little something. We'll have to see. And until next time, have a good one, guys.